Okay, let me try this. Testing, testing, and testing. Oops, didn't mean to do that. Oh, I didn't mean to do that. Hold on. Bear with me, waiting for it to give me a sound check. Testing. Okay, there's my sound check. Let's just jump right into this. Right into this deal. Alternators. Electricity. Think of an alternator as a generator. It's not for free. Electricity is not free. There is no free lunch. So this is a simple engine. There's a crankshaft at the bottom of the engine, or wherever it might be in your engine these days. It extends. The crankshaft runs is inside the engine, running the pistons. With that said, they extend this crankshaft further out with a hole through the engine, and in that hole they allow a part of more material to extend out, and it would be part of the crankshaft, a bar, and then well, sometimes they gear this, but this simplicity works good. So it comes through here, and then they add this pulley here. This is basically a pulley. It's what it amounts to. You can call it gears or not, but let's go with pulley right now. And then it gets to a pulley. Ultimately, you get to a pulley. This is that belt that it's on there. With that said, the engine, you undo this belt, you got an engine that works perfectly, no problem at all. Except for usually they put a fan here too that helps cool down the engine. So that could be an issue for you, depending on where you live, how the temperature that you're at, whether the fan belt would be that important at that point. But your car would then run. Your car needs electricity to run. So if your alternator generator went bad, you have a backup, if you will, the battery. The battery will last as long as it lasts, depending on your demands. You turn the AC unit on, you're going to have a higher increase in demands, and you will come to an end real fast. That's just giving you a general idea of what the alternator does. The alternator, think of it again as a generator. While your car is running, it's generating all the electricity you need to keep all those things running. Your brake lights, tail lights, headlights, turn signals, radio, all your electronics in your dash, electronics, all of it. And then think of the battery as the backup for that, temporary. It's actually to get you started. Your cold cranking amps, your startup amps, things like that. It's being charged after you start the car up. Then it gets a trickle charge from the alternator, keeping it stable. But this is your power plant, your generator. With that said, I like jumping to the chase. If you have an older vehicle, say you have a 2005 vehicle, it's now 2019. If I had to replace the alternator, I wouldn't just go to the manufacturer and say, hey, I want the original alternator. Well, that alternator is 14 years old. The technology in that alternator is 14 years old. Perhaps now I want an aftermarket alternator that has better technology, and the efficiency of my alternator / generators is more. The generators are not efficient. These alternator generators, and helping you understand that, they generate electricity. They can be as low as 45% to as high as maybe 80% efficient. Now, I don't know if you can find 180% everywhere. You have to look it up. Maybe you can look it up. Now, let's just talk about oversizing the alternator. Say my car says it only need a 65 amp alternator. I decide, no, man, 100's got to be better than 65. Well, the problem is I put a bigger generator on board, and a bigger generator uses more power to keep it working. So if I underpower this generator, if I don't have the right RPMs, etc., I'm underpowering my generator. It's not working properly. It could be a lot of things going on with that. There's a few other dynamics. In other words, you don't add an extra generator, larger generator, if you don't need it. Now, if you plan on running headlights, auxiliary headlights, and things like that, extra headlights, when I say auxiliary, then you want to see if your car address that. If your car's manual says, you know what, you can add alternate lights with this package, with the alternator that's existing. But sometimes when they upgrade a package, electronics package, if you will, like extra headlights and all this craziness, the generator will get upsized. So if you just can't add lights, you just can't do whatever you want to with your vehicle. You've got to know its range. And you can figure out its range again by looking at the packages And if you find like you have a Jeep and it says, "Oh, we got the extra headlight, runner bar lights," and you look at the package original equipment and it has the same alternator as your non-lighted, extra lighted Jeep has, well, you can say, "Oh, I don't need a bigger alternator. This has already been designed to take a more lights on that single alternator." So it's been over designed by that little bit. Or if I add a tow package and the headlights are on at nighttime and you're doing radio and all the other stuff, it's not for free. So let's jump right into it. It's not for free. This is an air conditioner, for example, on board a vehicle. It can take 20 to 21 amps while you're running it. The audio power amplifiers, 10 to 70 amps. Obviously, somebody's really jamming at that point. Backup lamps, 3 to 4 amps. So when you put your reverse lights on, you're using 3 to 4 amps now. You're using some alternator power. Again, if your car is already okay, let it ride. Now, the efficiency, when I said that 2005 vehicle, you want to check to see what the efficiency of the alternator is what it comes out to. That's really what it comes to, because you're going to save on this. Because if alternators, not if, alternators are inefficient, and let me talk to you about this. I don't like this page. I'm not negative. I have to talk about it in a critiquing way, and I can't explain why. But I'm critiquing it because I don't like this page, because I wish this was in color. And I can write you in the comments why. But the wish is in color, and I wish they had a tag here, and this just seems ridiculous. Okay, with that said, let's move on. The alternator you're going to replace, if you do upsize, this pulley matters. The RPMs of the engine at idle control how much energy you're coming out of here. So at idle, your alternator would ideally like to be able to run the air conditioner, the heater, not together, obviously, without putting a negative drain on the battery. You don't want to have it so you have a negative drain. So you just really don't at all. You like to know the baseline of this alternator at regular idle RPMs of your vehicle. It was designed to run all those things. Turn on your dome light, turn on your headlights, turn on your air conditioner. Well, the answer is kind of yes. If you come to a stop and you say, when did that happen? When you come to a stop, every time you come to a stop, your car goes to idle. That idle speed is not just about keeping your car running, but it's about keeping this alternator running, this generator running, to have your headlights on, all this stuff working while you're at a stop sign. So this matters. If you change this pulley and you get the wrong, you're changing alternators and you get the wrong size pulley, your ratios change. So this pulley, let's call this, I'm going to make it easy for you to understand. This pulley is 10-inch diameter. This pulley is a 2-inch diameter. So this turns, for every 1 revolution, this turns this one 5 times. If I were to change this to a 1-inch, for every revolution, this turns this 10 times. So you can see where it matters. And now it does, this is not for free. This generator actually is a drag on the engine. So if you use a bigger generator, the internal components just don't turn. If you put your hand on that and try to spin it, it requires a significant amount of torque to rotate it with your hand. That hand action comes from this guy now, the engine. So the engine is designed to maintain a certain RPM. Let's call it 800 RPMs. And if you would put a drag on it, say, let's just call it 100, a number of 100. I'm not going to call it any coefficient stuff, but say you put a new alternator on it and it's a drag of 100. And this engine was, before you put the new alternator on, the drag it normally saw was 80. The resistance it normally saw was 80. So this engine will work harder. Well, you can see how much harder. Actually, that's 20 goes into 80. It's like 25% harder at idle to maintain this alternator's power, its requirement, because of the drag and the resistance. That is the efficiency we're talking about, not just how efficiently it can convert electricity. How it does it is the drag is what I understand. Let me make that clear. What I understand, I leave myself open to changing data. So that is what's going on there. That's what's going on with your alternators. So you just don't pick an alternator to pick it, unless you're upsizing your motor, etc. I mean, not your motor. If you're upsizing your radio system, things like that. And again, that would be if you're at a stop sign at nighttime with the lights on, that would matter because you don't want to put a drain on the battery. Let's go to this final one. I think it's, no, that's what my man sent me. That was an accident. Wish him the best. I didn't like this site anyway. I didn't give me the direct link, All right. So there's your efficiency. That's the gist of an alternator / generator. The stator, this stuff converts, to DC current is what it amounts to. I'm going to give you the link to this right here so you guys can read it and enjoy it. Enjoy this link to this data and drive yourself crazy if you want. Simply stated, an alternator is a synchronous AC electric generator with DC diode rectifiers. Again, so it's going to change it to DC current, which your car operates on, and your efficiency is really, you got to look it up. Look up efficiency of alternators. You're going to get multiple answers. It's down. Tractor trailers, it might be 40%. They're running air all the time to keep their brakes going. Not all the time. When it leaks down, it starts up. Things like that. They're running, a lot more. So they're costing efficiency more so like in tractor trailer. This is not cheap, guys. You step an alternator up to the bigger size just for the heck of it, and it might, some charts try to scare you by showing in 250,000 miles you'll save $1,500 cost you $1,500 extra in 250,000 miles. If you use if you upsize by 50 amps, like a bus alternator, you have to do that. Find it yourself. I can't really share it on here because then we have copyright claim stuff going on. So I can't really do that. But if you do the calculations, you'll see what I mean by simply saying, okay, you said, let's call it $750. So 250,000 miles is what we're talking about. And oops. Oh, let me try something here. I'm trying to put some calculations in real quickly before I terminate the video. Yeah. So it's like, is that right? Yeah. Let me try one more. In other words, they try to downplay it like it's no big deal because they use a bigger number. If you shrink the number down, and it's instant saving. There's no reason to have a bigger motor than what you need. And I say motor, I'm referring to alternator. So I'm going to end this video. So when you're shopping for an alternator, this is my man Mac. He's having problems. He's getting confused by all the data. When you're shopping for it, if you got an older vehicle, see if you can upsize the efficiency of that alternator. Find out what the efficiency of your factory alternator is. It might be great. Who knows? You might be at 85%. That's awesome. Buy it again. And now if you can find, and maybe you'll find out it's 45% efficient if you can find any data on it all. And then you might find an 85% efficient alternator. So now your engine is going to run, it's going to take less horsepower to rotate that generator, if you will, to keep it running, to get the same equivalent power out of it. So all this stuff creates draw. If you have it on, it creates more draw. Your horsepower goes down because your engine has to dedicate horsepower or energy to making sure that resistant alternator is maintained in speed and RPMs. All right. So I'm trying to think if I can give you anything else on that. That's about it. And you can see me in the comments, and I'll reply in the comments if you need some further data, if you're not sure what I'm saying here. But take care, everybody. Take care. Let me see how I get rid of this. Terminate the video. Come over here. So again, buy factory. Go for the efficiency. Efficiency, the same size amps you need. Don't upsize it unless you have to, and then upsize it just to where you need to be. You think this future stuff, already calculate the exact future one. You can also trade off. You can go to LED lights if you've got a big enough vehicle and switch over to LED as opposed to all this other stuff. Halogen headlights versus HID headlights. All that stuff matters. And the video is terminating. Wish you all success.